So let's start the stream. Question number 1, identify and describe 3 stages of program development life cycle. So we know there are 4 stages of program development life cycle. First stage is called analysis stage. Second stage is called the design stage. Third stage is coding. And the last stage is the testing stage. Analysis stage, a process of investigation leading to the specification of what a program is required to do. So in this stage, we just investigate and find the requirements of the program. Second stage is called the design stage. So in this stage, we use the program specification from the analysis stage to show how the program should be developed. And we use the tools like Flowchart and structure diagram and the pseudocode. Third stage is called the coding stage. In this stage, we write the program code using a programming language, let's say Python, C, or C#. The last stage is the called testing stage. So the completed program is run with the test data to make sure that all of the modules interact correctly and program as whole work as intended in all circumstances. We use the test data to test the program, so we'll make sure that it worked properly. Question number 2, to take one box to show which task is part of the analysis stage of the program development lifecycle. So option A is testing, option B is coding, option C is decomposition, and option D is design. So we know that testing, coding, and design, these are the 4 stages of program development lifecycle. So the option C, which is decomposition is a part of what? It is a part of analysis stage. Question number 3, 4 description of stages in the program development life cycles are shown. Draw one line to link each description to its most appropriate program development life cycle stage. Not all program development life cycle stages will be used. So here you can see we have different stages like analysis, coding, design, evaluation, and testing. And here are the statements. Let's see which statement belong to which stage. The first statement is develop an algorithm to solve the problem by using structure diagram, flowchart, and pseudocode. So we know that we use structure diagram, flowcharts, and pseudocode in design stage. So the correct answer is design. Next one, detect and fix errors in the program. So we know that's the testing stage where we use the testing data to test the program. Next one, identify the problem and its requirements. So that's analysis stage. And the last statement is write and implement the instruction to solve the problem. So that's the coding stage. Question number 4, identify 3 tasks in the analysis stage of the program development life cycle. So the first task is to gather the requirements. Okay. Second task is to analyze the user's need. And the third task is to define the system specification. Question number 5, abstraction, decomposition, and structure diagrams are tools used during the program development life cycle. Identify the stage of the program development life cycle where they are used and describe what they are used for. So let's talk about the first one. First one is abstraction. So we use this tool in the analysis stage. So what is the abstraction? So to identify the key element required, discarding any unnecessary details and information that is not required. Okay. Let's talk about the decomposition. Decomposition is also used in the analysis stage. So what is decomposition? To break down a complex problem into smaller parts, repeating this until each part can be solved easily. So in other words, like we break down a complex problem into small manageable tasks. Next one is structure diagram. Structure diagram is used in design stage. So what is the purpose of structure diagram? It's a hierarchical diagram that shows how a computer system can be repeatedly divided into subprograms. Question number 6, state 3 of the components part of a computer system. So we know there are 4 parts. First one is input, process, output, and storage. Question number 7, draw a flowchart to convert the length in feet into centimeter, and the formula is length in feet multiplied by 30. So how we draw a flowchart? We start with this shape. Okay, and then what is the next thing to do? We need to ask the user to input the length of the feet. So we use this shape. Okay, so the purpose of this question is to make sure you know the shapes. Okay, which shape we have to use. Then next one is we need to multiply the length in feet multiplied by 30. So that's we use the process shape. So length in centimeter is equal to length in feet multiplied by 30. Okay, and then we need to output. So for output, we use the same shape as this one. So we simply write this, use this shape and say output LCM because we want to output this one. Okay, length in centimeters. And finally, we end the program. Like this one, stop. So look here. So input and output, they're using the same shape. Start and stop is also the same. And this shape, rectangle, is used for the process. Okay, draw a flowchart to add two numbers entered by the user. So how we can draw a flowchart? So first of all, we know that it starts with this shape, okay? And then we need to ask a user to input two numbers. So we can say input number 1 and number 2. Then we need to do what? We need to add them together. So adding number together is a process, right? So we simply use this shape. Rectangle total is equal to number 1 plus number 2. And then we simply output using this shape. So output what? Output total. And then we just close the flowchart. Question number 9, draw a flowchart to read two numerical values, determine the largest of the two values and output the largest value. So this time we have to make some decisions. Okay, we need to compare two values and then we need to decide which value is larger. Okay, so same thing, we start the flowchart with this shape and the start, and then we ask a user to input two values, so value 1 and value 2. Next, we have to make a decision. So the decision making, we use the diamond shape. Okay, so this shape is used. So is value 1 is greater than value 2. If this condition is true, okay, it has two possible outcomes. One is yes, and other one is no, or true or false. So if it's yes, we output we say, okay, we assign the value 1 to the variable max. Or if it's no, we assign the value 2 to the variable max. And then finally, we output the value of variable max. And then we can simply close the flowchart. Question number 10, draw a flowchart to represent an algorithm that reads a number and identifies whether the number is positive or negative. You should use standard flowchart symbols. Okay, so this time we need to do what? We need to find, draw a flowchart for the program that finds if a number is positive or negative. Okay, same thing. We start the flowchart. We ask the user to input a number. Then we will check the number. If number is less than 0. If it is yes, then we output what we say. Output the number is negative. If no, we output a message showing that a number is positive. And then finally, we can close the program. Okay. Let's see question number 11, develop a flowchart based on the provided code. So you have a code this time, okay, no statement, and you need to draw a flowchart for this one. Okay, so let's see how we draw the flowchart. So start the program. Next statement is score equal to 75. So this is a process. Okay, remember assigning value to a variable is a process. So we use the rectangle shape. So score equal to 75. Okay, so 7 is missing here. Then we have to do what? If score is greater than 50. So we use the decision is because it's an if statement. So we say is score greater than 50. Okay. So we have if yes, then we output the message passed. So if no, we don't have anything, right? So we can just say yes. Yes, we output a message passed, and no, we don't have anything, and then we can simply stop the program. Okay. That's how you create a flowchart from the pseudocode. Let's see another example, because this topic is very important. You have one question about how to create a flowchart in the exam. So let's practice this one, okay? Next question is develop a flowchart based on the provided code. Says the code mark is equal to 60. If mark is greater than 50, then output passed, else. This time we have else, okay, and output failed, and end if. Okay, so simply start the program. Then we have assigned the value 60 to variable mark, and then we need to check is mark is greater than 50. If yes, we output the message pass. If no, we output the message what failed, and then we can close the flowchart. Next question, develop a flowchart based on the provided code. So this time we have a code mark equal to 60. If mark is greater than 80, then output mark A. Else if mark is greater than or equal to 60, then output mark C. Else output fail, and if. So this time we're using if and else if statements. Okay, so let's see how we can handle those statements using the flowchart. So same thing, start the flowchart. Process is what? Is assigning 60 to variable mark, and then you have to check the first condition. The first condition is what? Mark is greater than 50. If it is true, we output a message what? Output mark A. If it is false, we have to have another decision, okay? If it's false, if no, then we have to make another decision. Is mark is greater than or equal to 60, this one. And if it's true, then we output the, if it's true, if we output what? Output the mark C, okay? And if it's false, we output the what? Failed. And finally, we can close the program. Okay. Let's see the next question. The following 4 pseudocode statements and 3 flowchart symbols are shown. Draw a line from each pseudocode. Okay. If x is greater than 12, so is this shape, diamond shape, and input x is what shape we use this shape. Okay, for this one, input and output, and this is x equal to z plus y plus z. This is a process, and the last shape is what output equals to x. So this is this shape. Okay, question number 15. What is the purpose of the following shape in the flowchart? So option A is represent a subroutine, option B represent a decision, option C represent an input output, and option D represent a terminator. So we know this is not the terminator shape, this is not the input output shape, also it's not the decision shape. So the correct answer is option A. It's this shape is used to represent a subroutine. Question number 16, draw the most appropriate flowchart symbol for each pseudocode statement. So first statement is if number is equal to 20. So this is the decision statement. So we'll use the diamond statement to represent the decision statement. Okay. Next one is number equal to number plus 1. So that's a process. So we use the rectangle shape for the process and the print number. So there's the output statement. So we use this statement for the output. Question number 17, describe the purpose of flow lines in the flowchart. So flowchart flow lines are use arrows to show the direction of the flow through the chart. Okay, which is usually, but not always, top, bottom, and left to right. Question number 18, an array called student used to store the names of the 20 students. The array is indexed from 0 to 19, so it is student 0 to 19. The name of the students need to be output using a loop. There are different types of loops that can be used. A precondition loop tests the loop condition at the start of each iteration. Draw a flowchart to show how a precondition loop can be used to output the names of all students. So now we need to draw a flowchart of precondition loop. Okay. So let's see how we can do that. So we start this one. Okay. Start the flowchart and then we set the counter to 0. Okay. And then we check is counter is greater than 19. So if this condition is true or false, right? So the counter is greater than 90 is no, right? And if it's no, then we output the what student counter. Counter is what? Counter is 0. So 0 will output the first element from the array student. And then we set the counter equal to counter plus 1. We are just adding 1 to the counter or incrementing counter by 1. And we repeat this process, okay, until the value of counter become greater than 19. Okay, so because it's a loop, and once the value of counter is greater than 19, and we can simply stop the program. Okay, that's how you can create a flowchart of the loop. Okay, so let's see another example. So same question, but this time we have to draw the flowchart to show how a post condition loop can be used to output the names of all students. So first we have saw the precondition, which is while loop, and now we are looking at the repeat until loop, which is post condition loop. Okay, so it's the same flowchart, but it's flipped. Okay, we check the condition at the end. So same start. Okay, then you have a variable counter to 0, and then you output student counter, and then you have increment the counter by 1, and then you check the condition at the end is counter greater than 19. Okay, and then if not, then you can just go back and keep running those lines of code until this condition becomes false, and then you stop the program. Okay, question 20. A program asks a user to enter 2 numbers. The program then adds the numbers together and output the total. Draw a structure diagram for the program. So now you need to draw a structure diagram for this program. So let's see structure diagram. So for creating a structure diagram, you need to first add the program name at the top, right? We know this one. Then you divide this thing into 3 things. First one is input, what are the processes, and what is the output. Okay, so now you need to find what are the inputs from this question. So we know we have 2 inputs. First one is number 1, and second one is the number 2. Now you need to see what is the process. Okay, from this question, so the process is to add those 2 numbers together. So we say number 1 equal to number 1 plus number 2, and we're storing the sum of those 2 numbers in a variable storage. And what is the output for this program is to output the sum. So we output the total. Okay. Question 21, a satellite navigation system needs to ask the user to input their destination. It then finds the route to the destination and output the instruction to the user. Draw a structure diagram for the system. So now you have to draw a structure diagram for this system. So we know that the first step is to write the program name at the top. So we write the program name, satellite navigation system, SatNav. Then we divide this program into 3 things. First one is input, second one is process, third one is output. Okay, so now let's see what is the input for this program. So we know that it's a one input is a user will input the destination. Okay, what is the process? The process is the system will find the route for the destination, and the last one is output. What is the output? It shows the direction to that destination. So that's how you can draw a flow structure diagram for every problem. Next, let's have one more example. So a login system a login system is required. The system asks the user to enter their username and the password. It checks if they are valid. If they are correct, the system output that they are correct. If they are incorrect, the system output that they are incorrect and prompt the user to re-enter their username and the password. Draw the structure diagram of the login system. So how we draw the structure diagram, same thing. We need to write the program or the app name at the top. Okay, for example, our system is what is a login system. Okay, then we divide this system into three parts. So what are the input for this system? What is the process and what is the output? Okay, so what are the input for this one? So user need to input the username and the password. So these are the two inputs. Now what is the process? So we have two processes here, right? The first process is what? First process is find the username and the password in the database, and then compare the username, the one user entered, with the one that is stored in the database, and then output is what? Output the message. First is if it's correct, it show the message that it's correct. If it's incorrect, you should show a message incorrect and also ask the user to re-enter the password. So that's how you create the structure diagram for a login system. Okay, take one box to in each row to identify if a statement is about structure diagram is false, true or false. Let's see the first statement. A structure diagram is a piece of code that is available through the structure of a program. Okay, so that is false. Okay, it's not a piece of code. A structure diagram shows hierarchy of a system. That's true. A structure diagram is another name of an array. That's false. A structure diagram shows the relationship between the different components of a system. That's true. Okay. Now let's talk about the test data. So we know that we have four type of test data. First type of test data is called the normal test data. So data that a program should accept is called the normal test data. Then you have abnormal test data, that the data that the program should not accept is called the abnormal test data. Then we have the extreme data that is at the edge of what is allowed is called the extreme data. And the last type of data is called the boundary data that is on the edge of being accepted and being rejected. So make sure you know those four types of data. And now let's go and see some questions. Okay. A program allows the user to enter 5 numbers between 1 to 5. Find the normal, abnormal, boundary, and extreme input values for the program. Okay, so how do we do that? So this is a program, it accepts only the numbers from 1 to 5. So this is our normal data. Okay, any number or anything outside of this range is called the abnormal data. Okay, so now let's see what is the extreme beta. So extreme beta is the first value, okay, start value and the end value. Okay, this is our extreme beta. Now let's talk about the boundary. So boundary data is what? So start value -1 and end value +1. So that's our boundary data. So I want you to take a screenshot of this picture so it may help you to recall this test data. Okay, so how you can find the test data for the program. Normal data, boundary data, extreme data, and abnormal data. Question 26. A program allows the user to enter their age as a whole number between 10 and 100 years inclusive. Give examples of following types of test data for the program. For example, normal data, abnormal data, extreme data, and the boundary data. Okay, so how we do that? What is the normal data for this program? So normal data, any number between 10 and 100, let's say 10, 20, 50, and 100, this is the normal data. Next, abnormal data, any data that is not a number between 10 to 100. So for example, 9, -1, 11, 200, age, or 12.2, these are all abnormal data. Okay. Extreme data, the largest number accepted is 100 and smallest number accepted is 10. So this is our extreme data. The boundary data is what? Either side of the largest bound 100 and 101 and either side of smallest bound 9 and 10. So that's our what? Boundary data. Question 27. A program asks the user to input number between 1 and 10 inclusive. Identify the test data for this program. I think it's very easy for you now. So the test data normal is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the abnormal data is anything less than 1 or greater than 10 or characters, string, etc. So these are the example here. Extreme data is 1 and 10 and boundary data is 0, 1 and 10 and 11. Okay. Question 28. A user needs to enter the password that is at least 8 characters long. Provide an example of valid test data for this program. So what is a valid test data? So let's see normal data. Any set of 8 or more characters, but they must be text. I have a speech mark example, this one. So this is our normal data. Abnormal data, any set of characters with 7 or less characters. For example, this and this is our what is our abnormal data. Extreme data, any with 8 characters only. This is our extreme data. Okay. What is the boundary data for this program? Either side of 8 character bound, or 7 character or 8 characters. This is our what is our boundary data for this program. Okay, question number 29, explain the purpose of using the test data in the software development and testing. So what is the purpose of using the test data? So the test data is a set of values used to determine whether a solution is working as it should. Okay, question 30, boundary data is one type of the test data. Identify and describe 3 other types of test data. So now you know normal data, abnormal data, extreme data, and the last one is boundary data. Okay. Give the set of boundary data need to check that a whole number is less than 50. Okay, read the question carefully. It's asking you the less than 50. So what is the answer? So 49 is inside the boundary and 50 is outside the boundary. So 49 to 50 is the answer. Question 32, take one or more box in each row to identify whether each statement refers to variables or the constant. Okay, and or constants. Okay. Okay, the first statement is you cannot change the value when the program is running. So that's constant. Okay, it has identifier. Both variables and constant have identifier. Identifier mean they have name. It is a memory location, so both variable and constants, they are the memory locations. Okay, so you can change its value when the program is running. So that is variable. You cannot change the value of variable. It stored a piece of data, so both stored a piece of data. Question 33, define the term algorithm. So what is algorithm? So it's a series of steps to solve a problem. So that's the definition of an algorithm. Okay. Question 34, what are the 2 required elements of totaling a program? So what are the 2 main requirements for totaling a program? So first of all, you need to initialize the variable to 0. And second one is add the value to the variable total. Okay, so these are the 2 requirements. Okay, so what are the 2 required elements for counting the program? Same thing. So first we have to initialize the count variable to 0, and second add 1 to the variable for each item. Okay, so that's the requirement for the counting and totaling. Okay, question 36. A programmer writes a program to weight basket of fruits in grams, keeping a total of the weight and counting the number of baskets. The total weight is stored in a variable called the total, and the name of the basket is stored in a variable called the basket count. Explain how the program can use these variables to calculate the total weight of the basket and the total number of baskets. Include example of the programming statement that would be used for totaling the weight and counting the basket. Okay, so let's see totaling. What is the totaling? So adding the weight of each basket to the total weight as each weight is entered, and here's how you can do the total. So total is equal to total plus weight. Counting, adding 1 to the number of basket as each weight is entered. So how you do the counting? So basket equal to basket plus 1. Basket count equal to basket count plus 1. Okay. Question 37, explain the difference between the programming concept of counting and totaling, and include an example of a programming statement for each concept in your explanation. Okay, so what is totaling? Totaling is used to sum a list of numbers. So how you do the total is equal to total plus number. Okay, so what is counting? Counting is used to find how many numbers or items there are in a list, and this is the example. Count is equal to count plus 1. Question 38, provide the pseudocode that perform the described tasks. First one is count control loop. So this is the pseudocode for the count control loop. You start with the keyword 4, then you have a start value, then you have a keyword 2, and then you have an end keyword, and then you have the statements that you want to execute, and then next keyword, and then you have to put the start. Next one is a precondition loop. Precondition loop is a while loop. Okay, so while loop, you have a keyword while, then you have a condition, then you have a keyword do, then you have a statements, okay, inside the body of while loop, and then you close the while loop with the keyword and while. Then you have a post condition loop. So post condition loop start with the keyword repeat, then you have statements, and then you have a keyword until, and after the until keyword, you have a condition here. Provide the pseudocode that performs the described task. So first one is totaling. So we know that first you have to create a variable total and initialize it to value 0, and then total equal to total plus number, or total plus something. Okay. What is counting? So counting, count is equal to 0, and count is equal to count plus 1. Average, so average is equal to 0, and average is equal to total divided by count. Okay, so before calculating the average, you need to have the total and the count. Otherwise, you won't be able to get the average. Okay, question 40. Provide the pseudocode that performs the described task. First one is if-else, and the second one is case-of statement. So you need to give me the structure of the if-else statement. So here you can see first you have a if, then you have a condition, then you have a keyword then. And then you have a statement that you want to execute if the condition is true. Then you have an else keyword, and after the else you have some statements, and those statements will be executed when this condition is false. Okay, and then you close this if-else with the keyword and if. Then you have a case of starts with the keyword case of, and then you have a variable here, and then you have the different samples of the values, for example, value 1, value 2, value 3, and value n, and then this is otherwise is the same as the else, and then you close it with the what end case. Okay, this is close, if statement closes with the end if, and the case statement closes with the end case. Okay, so let's say you have a variable, say the variable name, and you ask a user to input a name, and then you have some sample value. So let's say if user input the name is equal to John, then you just say some statement. If name is equal to AB, then you show some message. If the value is mapped, and then you can show some other message. Okay, let's move to the next question. Provide the pseudocode that performs a described task. So the procedure and function. So how you create a procedure and how you create a function. Okay, so this is the pseudocode for creating a procedure. First, you start with the keyword procedure, then you have a procedure name, and then you have the parameters for the procedure. Okay, so and then you have the statements that you want to execute inside the body of the procedure, and then you close the procedure with the end procedure keyword. The function, okay, the function, then you have the keyword function, then the function name, then the parameters, okay, and then you have to type the return data type. Okay, it is not important to specify the return data type here, but in the official pseudocode guide, they mentioned that this is the correct or the proper structure of the function. Okay, I would suggest you just go with function name, and the parameters. Forget about this one. Okay, and then you can add the statements here. And remember, do not forget the return if you are creating a function, because a function must have a return value. Okay, so return is a keyword, and then the value that you want to return could be a variable or anything. Okay, and then you close the function with the keyword and function. Okay, let's move to the next question. Okay, identify which of the validation rule, let me see. Okay, yeah. Okay, identify which validation rule is this algorithm uses. So which algorithm uses which validation rule. So we have input num, and if the num is greater than 0 and num is less than 100, then output valid, else output invalid. So what is this one? This is a range check. Okay, next one, identify which validation rule this algorithm uses. So we have a repeat loop. Okay, input value, the value is not equal to null, and value is not equal to empty. So that's the what? Presence check. Okay. Explain what is meant by validation and verification. Give an example of each one. Okay, so what is validation? Validation is checking if the data is reasonable and meets the certain criteria. An example is what? Range check, length check, type check, and check digit. Then you have the verification. Verification is checking if the data entered into the computer matches the original source. An example could be double entry check and the visual checks. Okay, question 45. Take one box to show, take one box in each row to identify if a statement is about the validation or the verification. Okay, so let's see the first statement, a check where data is re-entered to make sure no errors have been introduced during the data entry. So that's the what? That's called the verification. Okay, so that's what re-entered is what? Is double entry check. Okay, next, an automatic check to make sure that the data entered has the correct number of characters. So that's the validation. We can use the length check, okay, or format check. A check to make sure that the data is entered is sensible. So that is also the validation. Question 46, a program checks that the data entered is between 1 and 4, and 1 and 100 inclusive. Identify one piece of normal, extreme, and erroneous data for this program and give a reason for each. So what is erroneous data? We just know that we have 4 types of data, right? Normal data, abnormal data, extreme data, and the bounded data. But what is this erroneous data? So let's see. So normal data for this program is what? Is 50. Allow any number between 1 and 100 is inclusive. This is the normal data. Reason, the data that is within the range and should be accepted, we call it the normal data. Then extreme data, the data test data, for example, 101 is the extreme data. Reason, the data at the maximum and the minimum end of the range and should be accepted. Next one is erroneous data. Erroneous data is the other name for the abnormal data. Okay, so the test data example 300 allow anything that isn't between 1 and 100 inclusive, including other data types such as string, characters, and reason, data outside the range that should be rejected is the what? Is the abnormal or erroneous data. Question 47. Programs can perform verification and validation and verification checks when the data is entered. Identify two different types of validation checks and explain the purpose of each. So we know the first one is the presence check, ensure the data has been entered into a field, and then length check, ensure the data is correct number of characters or the digits. Range check, ensure the data is within a specified upper or and the lower limit. And then you have a type check, ensure the data is of a certain data type like integer or text. And then format check, ensure the data follows the specific pattern or structure. Question number 48, give the name of one verification check that can be performed on the data when it's entered into the program. So we know it's double entry check or visual check. Question 49, describe the difference between the validation and verification and context of data entry in the data entry in computer program. So validation is what is check if the data is reasonable or in the correct format. This is what validation does, okay? And verification checks if the data is accurate or matches the original source. Okay. Question 50, identify a suitable validation check for the email address test data. So this is the email address, okay, and describe how this validation check would be implemented and ensure that the validation check you choose is appropriate for verifying the format of an email address. Okay, so here we can see first we can say the validation check could be, we can use the length check. Okay, so length check is used to count the number of characters in the data to make sure that isn't too long, or max length is 320 characters. Okay, so we're done with the 50 question. Let's have a short break and then I'll back to you in within 2 or 3 minutes. Okay, so stay.